Welcome back. Today we're going to look at some tricks on how to use shortcuts to find out greatest common factors. And it's just a quick one to help you to sometimes just save time in tests and exams. If you haven't already joined me as a subscriber, you're welcome to press subscribe below. I have daily lectures. I've got over 200 videos on my channel, and you can always catch up on lost work as well. And then you can also go forward with us with our daily maths videos. They are only less than 5 minutes long, but they are gems. So now I want to just show you a few greatest common factor shortcuts. We know that we use the factor tree or the ladder method to find greatest common factor, but sometimes if you're pressed for time, you might find that some of these work. They work on certain numbers, and sometimes they can help you out very nicely. So you can check to see if the numerator can divide into the denominator. If it can, you've already found one of your shortcuts. Like these are some of them. Can this numerator divide into this denominator? Yes, it can. So we can automatically divide by 2 in the top and the bottom, and we end up with a half. Okay. Now this one, numerator, can it divide in there? Yes. So we know that's already the greatest common factor. Divide by 9, we end up with 1/9. Can this numerator divide into this denominator? Yes, it can. So we divide by 6, and we end up with 1/3. So this particular rule, number 1, to check if the numerator can divide into the denominator, does not work for all fractions, but very often it does. So that should be your first check to see if you're trying to save time to work out your greatest common factors when simplifying fractions. Let's look at another one that you can use. Number 2 of the list of tricks in your box would be to find out the difference between the denominator and the numerator. Okay, and that will be your greatest common factor. So here, let's look. 12 minus 8 is 4. So then we can actually use that as the greatest common factor. Divide by 4, and that would end up being 2/3. Okay. Here, 15 minus 12 is 3. So we're going to divide by 3, and we end up with 4/5. Here we have 20 minus 15 is 5. Divide by 5, and we end up with 3/4. Okay, so once again, doesn't work for everything, but it's a very valuable trick to have in your box, so that if you're trying to save time to find out greatest common factors for fraction reductions and simplifications, you use the difference between the denominator and the numerator. The last one is your division rules. And if any of these don't work, you simply resort back to using your ladder method or your factor tree method for greatest common factor. But let's look at the last one here. This is our division rules, and we're going to revise them quickly. 2 is going to be a factor of anything that ends in an even number. So a number that ends in an even number, 2 will be a factor. Okay. Any number that ends in an even number, 2 will be a factor. 3 is a factor if the sum, that means plus, is a multiple of 3. In other words, if it comes to something on the 3 times table. So if we had a number like 2, 4, 0, we would look at it like this. 2 plus 4 is 6, plus 0 is still 6. 6 is on the 3 times table, so 3 will be a factor. You add up the digits. And if they come to an answer of something on the 3 times table, 3 will be a factor. Now, 6 will only be a factor if both 2 and 3 are factors. If 2 and 3 are both factors with these rules here, you can automatically say that 6 is a factor. Okay, and then it'll be the GCF for that particular sum. Right, now let's look at 2 more. 5 is a factor of a number ending in a 0 or a 5. That's quite obvious because our 5 times table always ends in 0s or 5s, like that. Okay, and then 10 will be a factor if it ends in a 0, and that's also obvious because our 10 times table only ends in 0s. Okay. Right, so those are some things just to put into your bag of tricks that you can use to save you some time during tests and exams in order to get your greatest common factor. I'll see you in tomorrow's classes.